9.6, the converse of the Pythagorean theorem. So the word converse is sometimes confusing. It's a very math word, but really what we're just asking is it a right triangle? That's the question, and that's what the converse is answering that question. So tell if each triangle is a right triangle. So what we're given in all the past ones is that we can show, like, if it's on a coordinate grid, it already is a right angle, and right now it looks like it, but we have to prove it. So what we're doing here is, can we put a right angle here in that corner of our triangle? I'm not sure until we actually calculate it out. So to do that, we have to use our Pythagorean theorem, and that Pythagorean theorem states a squared plus b squared equals c squared. And we're going to use that to answer that question. So really what we're doing is, we're not saying it's equal right now, we're going to say, is it equal? And so I put a little question mark there to kind of answer that question. At the very bottom, we'll be able to say, yes, it is, or no, it's not. So to get the correct one in the right place, the main one, again, is our hypotenuse, which would be the longest side. So if it was the hypotenuse, this one would be it. So we're going to substitute that one in to C, and then A and B can be either of these. So A, we'll say, is 9, square it, and 40 squared for B is 40. So now we just simplify it out. Oh, we forgot our question mark. Is it equal? We don't know yet. And then, so 81 is 9 times 9, 40 times 40. Well, 4 times 4 is 16. And then the 10 times 10 is 100. So that would be 1600. And 41, that is not something. So I could do, on a non-calculator day, I would use the 41 times 41, a little sideline math. Or if I was able to use a calculator, I would use the calculator on my computer, and the Desmos is the best place that I like to go to. And would be 1681. 1681 is 41 squared. Now I'll add these two. So 1681, does that, question mark, does it equal 1681? And it does. So yes, it is a right triangle. And that is answering that question. So now I can go over here and put in that right angle. Only until I answer that question can I put that in. So now B, if we look at B, I can almost tell, but we have to prove it mathematically that it is not, or is, a right triangle. So I will start with my a squared plus b squared equals c squared. And notice, I don't know if you can really see, but these are decimal points here. So I want to use those. So the right angle would be across from the longest side, which is the 2.4. So I'll put that 2.4 in for the hypotenuse, which is the C. And then whichever one comes first, I'm going to use that one for A and this one for B. So A is 1.2 squared plus 1.8 squared. And the question is, are they equal? So when we multiply 1.2, well, that would be 12 times 12, which I do know is 144. And now I have my decimal, so I have one place value times one place value is two place values. And if I do 18 times 18, that's 324. And again, one place value times one place value is two place values. Bring down my plus, bring down my equals, bring down my question mark, and 24 times 24 is 576. And again, one place value times itself is two place values. Now, I like to break it into those two kind of thinking, place value and digits, because a lot of problems can be solved that way. So now when we add these up, we get 4.68. Does that equal 5.76? And it does not equal that. So what we've used is the converse of the Pythagorean theorem, basically stating, is it a right triangle? No, not a right triangle. And we've proved that. So that means that in this corner, we cannot put a right angle. Now, if we go down and look at a problem, so let's name this number 2, because that was 1A and 1B, and now we're on to, we want to tell if the points A, right here, B, and C form a right triangle. Now, it almost looks like it, but I can't tell for sure. So what I'm going to do is, what we do is, there's a little thing is that you kind of do a little bit more complicated. Well, not complicated, it's multi-step is what it is. So what we're looking at is A, B, and C for those points. So this math work, do you see the distance D sub 1? Really, that's our C, and they call it distance for 1 because it's just D as in distance on a coordinate or a coordinate plane. So they're just using the Pythagorean theorem to find this line right here. So notice we have a right angle because I can put it in right now because it is a coordinate grid and it is right angles. That's what the definition of a coordinate grid. So we substituted 2 in for B and 4 in for A, and then found that it was 20. We took the square root of both sides to cancel out that squared, and so that C, I kind of like the C better than that D sub 1. So C equals the square root of 21. So I'll kind of tuck that in here, and it's hard on the grid, so I'm going to pull that out here in a second to kind of do the math in the next step. But I want to take a look at this other triangle here. So I'll make that one purple here. So that distance is this work over here. Same kind of setup, we just have to do it again with, instead of, we have a 1 for A and B is 2, and then we're solving for that C. And the reason why we use like the 2 is because it's kind of C and C, you have lots of C's, so this is the second one. And remember, to cancel that out, we take the square root of both sides in that solving. So the C of this one, this angle right, or this distance right here, is the square root of 5. So now we have, and then we have a third length right here of 5 units. So I'm going to pull that triangle out and rewrite it. So this is probably what you want to put on your paper, is that 5, the square root of 20, and down here is the square root of 5. So the question we're answering, we're using that converse question, converse of the Pythagorean theorem. Is this a right triangle? We don't know, and I can't put it in there. I kind of have a guess that it might be close, but it could be a half a degree off, and we can't visually see that in our eyes. We would say that it is a right triangle, but technically it is not. So I'm going to start with my a squared plus b squared equals c squared. So now notice that I'm using a different color. So this Pythagorean theorem is kind of the third Pythagorean theorem that I have to use to solve this question. It's a little bit more complicated, more steps, but it's in that organization of that. Now, another way this could be written is if we had in order, it could be given to us as the square root of 20 the square root of 5, and 5. So the question is do these three side lengths make a right triangle? Now, the problem is it looks like that the square root of 20 is the longest side, but it's not. If you look at our picture, it's the 5. Now, so when you have the square root, it's actually easier to go and make everything a square root. So then you can compare which one's the biggest. So 5 times 5 would be the square root of that 25. So that 5 times 5 is that 25 in there. So I know that this 5, or square root of 25, is my C. So that's the important one that has to be over here in the C. So we're going to ask our question, put a question mark. So over here, I'm just going to substitute that square root of 20 in for A, and I put it in a parentheses to square it, and I'll put it in the square root of 5 in a parentheses and square that. Now, thinking about the square of a square root, remember, that cancels out, and that's the cool part. It looks like it's going to be complicated at the beginning, but it actually is really easy to solve these problems because those cancel out. We know how it undoes it. A square undoes a square root. So we're left with 20 plus 5 equals 25. And does 25 equal 25? And it does. So yes, it does. So this is, now we can go over here now. Yes, it is a right triangle. So we can now put in our right angle. And only when we have this true statement. So now if we kind of think about that and use that as another example, because sometimes they give it to you in just straight up numbers. So the square root of 27, 4, and the square root of 10. Does this make a right triangle? Is it a right triangle? Now, I don't know. Some people, what helps sometimes is to make it a right triangle. Well, no, I'm not going to make it a right triangle because that's what the question we're going to ask. I'll make it look close to a right triangle. Now, which one will be our C up here? That would have to be this one across the longest side. So I'm going to make these all into the square root symbols. So the square root of what is 4? So that's 4 times 4 is 16. The square root of 10. So the square root of 10 is my smallest. The square root of 27 would be my C. So now I'm going to write formula. A squared plus B squared equals C squared. Now I'm going to substitute, and remember the key is to get this square root of 27 in the right place. And that is the correct, the hypotenuse one. So the square root of 27, and we'll square it. Now we'll substitute the other ones in, the square root of 16 squared plus the square root of 10 squared. All right, so now my square root of squares cancels out, these square root of squares cancels out, and these square root of squares cancels out, and we're left with 16 plus 10 equals 27. So that would be 26 equals 27, and that is not true. So we'll not a right triangle. Now, we can state that it's not a right triangle because we have all of this math work to prove that it is not. And so you need that evidence to back up your claim.